Welcome to my individual demo reel for the augmented reality project Horror Gallery. In this video I will be presenting and explaining my contributions to the project. I was mainly responsible for spatial interaction programming and special effects, while my teammates focused on enemy AI and scene setup. Our team had strong synergy as we split tasks into clearly defined sections using a prefab based architecture and composition of individual scripts to avoid overlap. This was important as we used GitHub source control, so with careless merging we could result in overwriting each other's work. Development began with the wall-mounted frames. I generated a shatter effect in Blender and imported it as a rigid body into Unity. An additional twinkling effect was added in to indicate the interactivity of the user object. The frame emits a custom atmospheric smoke effect implemented with a billboard particle sprite system using transparent smoke textures which I built in Photoshop. A smoke effect is also placed on the real floor, environmentally integrating the digital scene into the user's world. Additionally, I developed the portal effect and modeled and textured the mansion entrance to enhance the scary theme of the experience. Planning and implementation of hand tracking were the most challenging aspects of this application. Gesture-based recognition must be intuitive for the user but functionally accurate enough for the puzzles and combat mechanics. In hindsight, I would have organized this code more efficiently. While the features are separated by class composition, the scripts contain many unnecessarily referenced variables. Ideally, the input handling, state changes and visual effects would be completely self-contained in another version of this application. I chose a pointing and a thumbs up gesture-based interaction due to their familiarity. Diegetic UI elements follow the appropriate hand using linear interpolation. Interactions are divided between gestures on the left and throw-based interactions on the right to manage cognitive load. The laser interaction fire point was initially positioned at the fingertip of the pointing finger. However, during our rapid prototyping stage, user participants tended to point using their wrist rather than their finger. As a result, I repositioned the fire point to pivot from the wrist instead. When the player points, a laser gun prefab is displayed. My findings were that in mixed reality, physical in-world indicators were more effective at steering players than non-diegetic screen-attached UI. During late-stage playtesting, I observed that the enemies felt less threatening without clear visual feedback. To create the presence of danger, I created a spherical bubble around the head, which increasingly darkens to indicate when the player is attacked. I also implemented a kickback effect on the player's weapon to help manage multiple enemies using impulse force. The flying enemies were programmed to a natural movement pattern with vertical oscillation. The throwable torch object has visual and audio feedback when the player picks it up, which works to improve immersion, inferring the player's role as an art thief. Additionally, its pose is offset towards the bottom of the handle to show a realistic grab effect. A technical hurdle we didn't manage to overcome was hand pose detection for throwing interactions. Players consistently found it difficult to throw objects as they would naturally extend their arms behind their back. If I were to tackle this project again, I would maybe use a Quest Pro or room-based solutions instead.